All right, this is Mr. Ellison, and we are going to do a walkthrough for the 2020-21 pre-calculus school year, assignment PC 6.7. It's a Khan Academy assignment. There's two Khan Academy 4-question things to do. And it's using the trig stuff to find angle identities and trig values using angle identities. So you're going to need to do this assignment, you will absolutely 100% need this worksheet. If you don't already have it, not worksheet, it's an information sheet, and you can get it. Go to Pre-Calculus Honors on my website, and it's the first, you can't see it because I had to long press to get it to stay, but it's Pre-Calculus reference materials, first menu item. Right down here, it's the Common Final Exam CFE reference sheet. We don't take a CFE in here, but I'm staying on pace with public schools so that you are prepared for whatever may come. So here we go. So we got using trig angle addition identities and finding trig values using angle identities. So the first one, using trig angle addition identities. So here we go. And we'll just solve a couple of them for you. And hopefully this will be helpful. Okay. So the first thing we have to remember or notice or whatever is that other than the fact that I still have to use the giant pen that comes with the recording program. So it says to find the sine of angle ABC, right? So that's unusual for us. What we would just think of as angle B. So when you're doing problems like this, it's just get all sketchy. Get sketchy and mark things up. Okay, so that's what we're looking for is angle B. So they want us to find the sine of angle B plus what? 6, or does that say minus? Oh, minus 60 degrees. Okay, that's fine. Let's start with -1. How come I can't erase? What? That's weird. Okay, well, whatever. I guess I won't erase. Huh. So we'll just do that. Sorry about that. Find sine of angle B minus 60 degrees. So the first thing you're going to do is look for something on the sheet. There's our sheet, and what we're looking for is a sine of an angle minus another angle. So sine of an angle minus another angle is going to be right there. So we'll use that one, and now we'll go back here and write it down. So that is going to be sine of A minus B equals sine A cosine B plus, oh, I'm writing it wrong. Okay. Sine A cosine B minus cosine A sine B. So now what we have to do is figure out the sine and cosine of A and B. So the thing you got to remember is that A and B are not linked to the A, B, C on the triangle. The A and B are these positions. This is the A position, and this is the B position. Because this little identity is about, what am I trying to do? This little identity says sine of A minus B. So that's what these are not referencing the angles on the actual triangle over there. Those are the positions in the equation. All right, so back to do, I don't know how long I'm going to have here, so we'll just get, so basically we've got A and B, and we need to find the sine and the cosine of A, and the sine and the cosine of B. So our A angle is actually angle B in the triangle. So we'll say cosine of B equals, and we'll just write SOHCAHTOA because you can't ever write that too much. Sine, a cosine of B is the adjacent over the hypotenuse. So that's 8 over 10. And the sine of B is opposite over hypotenuse, which is 6 over 10. And you can reduce those if you want or not. And then for angle B, for the B angle, that is, we're looking for the cosine of 60 degrees and the sine of 60 degrees. And for this, you have to go to the unit circle. So I guess we better just go to the unit circle. Get one of those up. Should have got that up ahead of time. Oh well. Not going to start over now. Here we go. Unit circle. It's not hard to find. Not hard to find at all. That first one was too big. It didn't fit on the screen. So I'm going with the second one. I'm going to open that up in a new tab. Open image in new tab so that I can see it like that. There we go. Okay. So what are we looking for? We are looking for the sine and the cosine of 60 degrees. And remember, you do have to know how to construct this yourself. Here's 60 degrees right here. 60 degrees. So, and you remember on the unit circle, the coordinates are cosine, comma, sine. So the cosine is 1/2, and the sine is square root of 3 over 2. The cosine of 60 is 1/2, and the sine of 60 is square root of 3 over 2. I'm just going to double check that. Cosine 60, 1/2 square root of 3 over 2. Good. All right, so now we have all our stuff, and all we have to do is put it in, right? So angle A, the sine for angle A, which is actually angle B on the triangle, is 6 over 10. And the cosine of the B angle is 1/2 minus the cosine of the A angle, which is 8 over 10, times the sine of the B angle, which is square root of 3 over 2. And then you just have to, do the math. So multiply those together, and you're going to get 6 over 20 minus 8 square root of 3 over 20. And then obviously that's not any of the answers, so you got to reduce that. So let's 6 divided by 2, because that's a common factor between 6 and 20. So we'll go 6 divided by 2 is 3, and 20 divided by 2 is 10. Is there a oh, there is 3 10s, so we're definitely on our way. And 8 over 20 is going to be, we can divide 8 by 2 is 4, divide 20 by 2 is 10, so that's 4 over 10, but we can divide both of those by 2 again, so it's going to be 2 over 5, 2 over 5. And then anything that's in the numerator, it's just multiplied by the thing, so you can leave it sitting up on the numerator, or if you like, you can take it outside the fraction if you want. So that is what I came up with, and is that an answer in there? 310 minus 2 over 5 square root of 3. It is, in fact, an answer, and it is answer C. Let's see if I got my gold star. Woohoo! I'll keep being a teacher. All right, we've got to erase all this stuff. Okay. Here we go. That didn't erase everything. So weird. So weird. Why is it messing up on me now? Okay, so we're going to have to just ignore that stuff. Unless I could select it. Nope. Oh, okay. And it's not erasing. Yeah, that's what happened before, right? Okay, too bad. So sad for me. We'll just use a different color. All right, so now it says to find. Okay, this is a good one. Okay, so I apologize for that. I wish there was something I could do about it, and yet there is nothing. So we need to find, and I won't use any blue, find the sine of 2 times, and it's angle BAC, right? So we use that middle letter, that's the point of the angle, 2 times angle A. All right, so we have this is called a double angle. So now we're looking for sine of 2 times something, right? And we have one of those. It says that the identity is this: sine 2x equals 2 sine x cosine x, where x is the angle, obviously. So we don't know the angle, but we can know the cosine and the sine exactly, right? Because the cosine and the sine are the ratios of the legs of this triangle. So that's A, so good thing we got colors here, right? So this is the angle we're not worried about it. This is the angle, in question, the suspect in our investigation, or whatever you want to call it. So we're just going to find the sine of A equals what? Well, the sine, let's write it again. Can't write it too often. So katoa. The sine is the opposite over the hypotenuse. So the sine of A is going to be 4 over 5. And the cosine of A is going to be the adjacent over the hypotenuse. So that's going to be 3 over 5, because the adjacent is the one that is touching the angle in question, and the opposite is the one facing the angle the angle that opens up to face the one in question. Okay, so now all we got to do is put in our stuff, right? So now we got 2, and we know the sine of the angle is 4 over 5, and we know the cosine of the angle is 3 over 5. So now we got to just do that. And that's going to equal what on top is going to be 2 times 4 is 8, times 3 is 24. 3 times 4 is 12, times 2 is 24. Just do it 2 different ways to make sure I'm not messing up my mental math. 5 times 5 is 25. Not going to be reducing that anytime soon, are we? So let's put that one in. 24 over 25. 24 over 25. Gold star. Okay, so that's the 2 kinds of problems, and if you lay them out that way, how much time? I think I have enough time to go on to the other assignment. So that's what I'm going to do. But if you just got to lay them out, so you got to figure out which identity equation. That's what an identity is. This equals that. It's an identity. So you got to look at what you need to find, and then list. Just if you need a process. Start by listing what you need to find, and make sure you understand where that is on the triangle, because the triangle labels may not be the same as the labels within the identity equation or whatever. Then just write that actual equation out so you can see what you have to figure out, right? And then after that, go find once you like have listed what you have to figure out, then you just go find what you need. I need the sine x and the cosine of x, and remember those are ratios, so you can find those with 100% precision, and that's what they want us to do. And then once you find those things, then you just take each one and stick it, where it goes in the equation, and do your math, and you're done. So that's the end of that one, and now I'm going to go on to another one. I wonder if it's going to delete all the ink when I close the tab. I'm hoping so. Oh, good. That's a nice thing. I wonder. Okay, so find trig values using angle addition identities. This is the one where you have to figure out what two angles can add up to the angle that you need. So this is a little bit, it's kind of just going, it's one more step. So we don't have 15 degrees, right, on our unit circle. We have, maybe let me erase that. Yes, good. Things are working. So we need to find, it's asking us to find the tangent of 15 degrees. And so this is going to cover everything because the tangent ones are a little more complicated, and I hope I can get it done. So the tangent of 15 degrees, that's what we want, whatever that is. And so what we have to do is we have to figure out two angles that we can add or subtract together, because we have angle addition quantities and angle subtraction identities, right? So we need two angles that we can either add or subtract together to get to 15. And if it was, we might have time to do one with radians, which will get us into the pi stuff, which tends to be a little bit different. But let's go. Okay, so what two angles can we put into an equation that will give us 15? Well, it's pretty obvious, I think. If we do 45 degrees minus 30 degrees, that's going to give us 15 degrees. But we can't just say, okay, well, the tangent of 45 minus the tangent of 30, because it doesn't actually work that way exactly. So we know the two angles that we need, and we're going to need, let's go back here. And now what we got to do is find, so here, so that's a subtraction, right? We had to subtract to get there. And you can subtract or add to get anywhere you want. But that's what we had to do here. So we're going to go back here, and it wants a tangent. So we got to look under difference, because that's subtraction, right? Sum is addition, difference is subtraction, and it's a tangent. So let us do this. So I'm going to write down the formula. Just write it on down right here. The tangent of A minus B, oh, I hope I left enough room for myself, equals the tangent of A minus the tangent of B over 1 plus the tangent of A times the tangent of B. And God bless the person who figured these things out. So, but that's our identity. We know that that equals that for the tangent. So now we've got two angles, and we just have to figure them out, right? So let's figure out our angle A and B. Let's go back over here. Our angle A will be 45, and our angle B will be 30. Because 45 minus 30 will get us to 15, right? So for angle A, we want the tangent of 45 degrees, which equals what? Well, that's a exceptionally easy one, because 45 degrees, if you remember, is an isosceles triangle. The x and the y legs are the same, and the hypotenuse is different. So if we go to 45 degrees, the tangent of 45 is square root of 2 over 2 over square root of 2 over 2. I'm going to write that. If you already know what this is, you don't have to write this, because that's 1. And I'm writing it so small because I'm going to leave it away. I'm going to just leave it right there. So the tangent of 45 is 1. And that's our A angle. Now for our B angle, we need the tangent of, well, it was 30, right? Yeah, 45 minus 30 is 15. I almost jumped back there. Okay, so the tangent, remember, SOHCAHTOA, Can't write it too much. The tangent is the opposite over the adjacent. And just remember, there's this cotangent function that is the opposite that might come up, and that would just be the adjacent over the opposite. But don't worry about that now. I'm just trying to throw in extra stuff. So the tangent of 30 degrees is the opposite over the adjacent, and on the unit circle, it's going to be the y coordinate over the x coordinate. So we'll go to the unit circle. Go to the unit circle. The y coordinate over the x coordinate, because that's the x and that's the y, right? So it's going to be 1/2 over square root of 3 over 2. So it's going to be 1/2 over square root of 3 over 2. So the first thing that's going to happen is those 2's are going to cancel out. So all you're going to be left with is 1 over square root of 3. And all of a sudden, things don't look so desperate, do they? All right, so now for our tangent of A, that's going to equal 1, right? So let's just start doing this. So tangent of A equals 1 minus the tangent of B, which is 1 over the square root of 3. We're going to get into a little trouble here in a second. When you have something on the bottom of a fraction and there's difference and there's not a common denominator, you know you're going to end up in trouble. But we'll get out of trouble. 1 plus the tangent of A, which is 1, times the tangent of B, which again is 1 over square root of 3. Now, what are we going to do with this? So if you have fractions on the numerator, if you have a fraction in the numerator and a fraction in the denominator, one of the things you want to do is try to get that to be a single fraction. And so what I'm going to do here is, boy, this fat pen makes it hard to write. So I'm going to put square root of 3 over 3 in for that 1, minus 1 over square root of 3. And then I'm going to put square root of 3 over 3 in for this one too, for that 1 that's on the bottom. And that's going to be plus, and that 1 disappears, of course, 1 over square root of 3. All right, so now that is going to give me, I can combine those two now because they have a common denominator. So I'm going to have square root of 3 minus 1 over the square root of 3. And on the bottom, I'm going to have square root of 3 plus 1 over the square root of 3. Now remember, if you have a fraction in the numerator and a fraction in the denominator, and the denominators of those subfractions, whatever you want to call them, are the same, you can just drop them out. They no longer apply. So that leaves us with, and I'm going to put it down over here now, that leaves us with the square root of 3 minus 1 over the square root of 3 plus 1. And is that, do we have that as an option? We sure do. It's number 1, and that's all I have time for. So I hope that was super helpful. Just double crazy helpful. And it was correct. I got my gold star. So that was pretty, this extra fractioning work, that was a little extra complicated. And that is it. Let me know if you need more help than that. Have a great day. Bye.